Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
Every 30 seconds, somewhere in the world, the ground shakes. Most earthquakes are too tiny to be felt, but some can be devastating. Why do earthquakes happen? What should you do during an earthquake? Well, we're here to answer your questions. Stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek, and welcome to Boise State University's Seismology Lab. We're here to answer your questions about earthquakes. But before we do, let's learn a little bit more.
The Earth is made up of three main layers. The center, or core, which is very hot. Around the core lies the mantle, a thick layer of mostly rock and some liquid. And floating on top of the mantle is the Earth's thin outer layer, called the crust. The crust is made up of separate slabs called tectonic plates. The solid rock of the crust is under constant pressure from the movement of the plates. As a result, giant cracks or fault lines are created. When plates try to slide past each other along a fault line, sometimes they get stuck. The pressure builds up until the plates suddenly break apart, causing a powerful ground movement we call an earthquake.
You can see why an earthquake can cause a lot of damage. Put two wood blocks together and cover them with a layer of sand. Put a few buildings and animals on top, and then move one of the blocks. And that's what an earthquake looks like.
The spot on the Earth's surface reached by the first wave is called the epicenter. From the epicenter, seismic waves, or shock waves, spread outward. Scientists measure earthquakes with a special tool called a seismograph. The seismograph's pen records shock waves by drawing lines on a piece of paper. When a wave is closer or stronger, the line is longer. When the wave is farther away or weaker, the line is shorter. Another thing scientists look for is the intensity and magnitude of an earthquake. The intensity is the damage that people can see and feel. The magnitude is how strong the surface of the Earth shakes.
Scientists use a special scale called a Richter scale to measure the intensity and magnitude of an earthquake. The higher the number, the more severe the earthquake. Say this marble represents a magnitude 1 earthquake, then a golf ball would be a 3, a baseball would be a 4, and a soccer ball would be a 5. The largest earthquake in the world so far happened in Chile in February of 2010. That quake measured 9.5 on the Richter scale. So if it were a ball, it would be about this size.
One of the most famous earthquakes in U.S. history was the 1906 earthquake in San Francisco. That earthquake leveled 500 city blocks, killed 3,000 people, and left 225,000 people homeless. One of the largest earthquakes in Idaho history was the 1983 quake near the town of Challis. 2 children died when a storefront collapsed on top of them. And in that quake, Mount Bora, Idaho's highest peak, rose about a foot and then fell back into place. Earthquakes just don't happen on land. They can happen in the ocean, too, and can be just as destructive. The shifting of the ocean floor can cause a giant wave called a tsunami. Because a tsunami contains so much energy, it can race across the ocean for thousands of miles at speeds of more than 500 miles per hour. And when it reaches land, the height of the wave can be over 100 feet tall. Scientists have no way of predicting earthquakes, so it's a good idea to have a disaster kit at home. You should have a fire extinguisher, a first aid kit, and enough water so everyone in your family can have enough to drink for 3 days. You should have an emergency plan so everyone knows where to meet after an earthquake. And make sure you or your parents have a person out of town you can contact so they can let everybody else know you're okay. During an earthquake, if you're inside, get under a strong table and stay away from windows. And if you're outside, stay away from buildings, trees, and power lines. Scientists are studying earthquakes in hopes of someday learning how to predict when they will happen. That could save lots of lives. But for now, we don't know when the next earthquake will strike. The best thing you can do is find out what an earthquake is, and then be prepared.
And joining me now to answer your questions about earthquakes Jeffrey Johnson, a geophysics professor at Boise State University. And joining us in our Moscow studio is Dennis Feeney, a senior geologist with the Idaho Geological Survey at the University of Idaho. Thank you, Dennis, for joining us there.
Hi, Joan. Hi, Jeff. Thanks for having me here.
And Jeff, thank you for joining us here.
Thanks, Joan. I'm happy to be here.
Okay, let's go to your questions.
Hi, my name is Deshaun, and I go to Camet Elementary School in Camet, Idaho. My question is, how do earthquakes start?
So, Deshaun, earthquakes happen when the crust breaks. If you think of the Earth as a giant rubber band and you keep stretching it to the point where that rubber band breaks, that's what the Earth's crust is doing.
Hi, my name is Jalen. I go to Reed Dual Language, and my question is, why are there aftershocks after earthquakes?
Well, there are aftershocks after an earthquake because once the pressure is released from one spot, pressures are built up or adjusted into other spots, and they have to be released as well. So the Earth likes to be in what's called equilibrium, or where everything's at a nice, happy balance. So aftershocks will happen around that earthquake, but due to pressures being adjusted, so it wants to be stable and happy.
My name is Emma, and I go to Pioneer School of the Arts. And my question is, what is the biggest earthquake ever?
The biggest earthquake that has been recorded in modern times is the 1960 Valdivia, Chile earthquake. This earthquake was so big that it ruptured a segment of fault that was 500 miles long, and the ground moved something like 60 feet all at once. That earthquake was some 10 times larger than the next largest earthquake that's occurred in historic times.
Kate would like to know, what is magnitude?
Magnitude is a mathematical way that scientists use to put a number on measuring the size of an earthquake. So what a magnitude does is it's a scale that goes from 0 to 10. And every step increase up from 1 to 2 to 3 to 4 to 5, all the way up to 10, represents how much shaking there was. And each time you go up one whole step, it's 10 times larger than the last one. So magnitude is what we use to describe, a mathematical way we use to describe an earthquake, a measured value of an earthquake.
With regards to magnitude, one important thing to remember is when you go up one increment in the scale, you increase the energy of the earthquake by so very much. So a magnitude 7 earthquake actually has 1,000,000 times the energy of a magnitude 3 earthquake.
Curtis would like to know, what is a seismologist?
Curtis, the word seismos is Greek for earthquake. So any of these seismo words that you hear about have effectively earthquake as a root. Seismologist is a person who studies earthquakes. Seismograph is an instrument that records earthquakes. Seismology is the study of earthquakes.
Hi, my name is Davis from Dalton Elementary in Dalton Gardens, and my question is, why does the earth crack during an earthquake?
Well, Davis, the earth cracks as stresses that have accumulated in the earth all of a sudden are released through the fracturing or brittle failure of the crust. So an earthquake represents breakage of rock that happens suddenly after stresses have accumulated over long, long periods of time.
Hello, my name is Sam, and I go to Galileo STEM Academy, and my question is it possible for a tectonic plate to split apart during an earthquake?
It's very unlikely that a tectonic plate will split apart during one single earthquake. Tectonic plates are very, very thick, and earthquakes are really more smaller scales. So it's really unlikely that an earthquake can rupture through a whole tectonic plate.
Yeah, I'll add that earthquakes that happen in certain places in the world are working towards the breakup of tectonic plates. For instance, in the middle of our oceans, like the middle of the Atlantic Ocean, earthquakes that are occurring along the mid-Atlantic ridge are small movements associated with the opening up of the Atlantic Ocean. And believe it or not, even in western North America, in Nevada and extending into Idaho, we have earthquakes that are stretching the crust apart. But those earthquakes won't rip apart the tectonic plates all at once.
Sam would like to know, what is the Ring of Fire?
The Ring of Fire is a geographic lineament that goes from South America all the way up to Alaska, around to Japan, and then down to Indonesia. It represents the end boundaries of the Pacific Plate. It's a zone in the Earth, so it is the tectonic plate, the edge of the tectonic plate, and it's a zone where there's a lot of volcanic activity and earthquake activity. And because of that, there's a lot of loss of life or hazards that come along living along that region of the Earth.
People think of California when they think of earthquakes, but Alaska accounted for more than half of all the earthquakes in the U.S. in the past few decades. So who's on the bottom? A number of states have had no earthquakes in the last 25 years. And what about Idaho? We rank 6th, so be prepared.
Hi, my name is Haley, and I go to Kamiah Elementary School in Kamiah, Idaho. My question is, what was the most famous earthquake in the world?
I think this is a good question for both of us to answer. The perspective matters a lot when you ask the question, what is the most famous? Depending upon where you live, you may have a different idea of which is most famous. But one earthquake that's commonly thought of as very significant is the 1906 San Francisco, California earthquake that resulted when the San Andreas Fault moved suddenly. And that earthquake was responsible for destroying some 80% of San Francisco.
The one that Jeff noted was actually really a good one to put on the list. I think there's multiple earthquakes I would put on the list. And unfortunately, earthquakes become famous because they either destroy a lot of buildings or towns or infrastructure, or they hurt a lot of people. They cause the loss of lives. So earthquakes are more infamous, and there's a lot of them. I actually created a small list. I would say the Sumatra earthquake in 2004 was a magnitude 9, which led to a tsunami, which lost a lot of lives. The Haiti earthquake in 2010 was a magnitude 7, where a lot of lives were lost, and the infrastructure of Haiti was well destroyed. In 2011, there was the Fukushima earthquake, which was a 6.9, which caused a tsunami, and it caused some damage to nuclear reactors in the area. So there's a list of a lot of really famous earthquakes. And really, once again, the measurement is how much damage it does.
Hi, my name is Easton. I go to Dalton Elementary School. My question is, how long does an earthquake last?
Easton, when an earthquake happens, the ground shaking can last for a long, long period of time. Most people will sense the ground shaking corresponding to big earthquakes, and in some of the largest earthquakes, the ground is shaken for several minutes in duration. One of the interesting things that seismologists study is just how the Earth responds to big earthquakes. Some of the largest earthquakes that have occurred in the last decade have caused the Earth to continue to shake and ring detectably with seismometers for up to several months. Now, humans can't sense that, but sensitive instruments are able to detect that long-term shaking.
Hi, my name is Haley. I'm from Dalton Elementary, and my question is, how many earthquakes happen in a year?
Haley, that's a good question. There's a wide number of earthquakes that happen in a year. And it changes year to year, but it's on the order of hundreds of thousands of earthquakes happen around the world in the year, most of which we can't feel as humans, or most of them are under the magnitude of 3. If we take just Idaho, for example, last year there were 388 earthquakes in the state of Idaho, and I believe it was 380 of them could not be felt by humans. So there's a lot of earthquakes that happen, and Idaho has its fair share of earthquakes. But the majority of them happen in places all over the world. And like I said, maybe over 100,000, in the 100,000s.
Yeah, I'd like to add to this. On an average year, there's about 1 magnitude 8 earthquake that occurs globally. In an average year, magnitude 3 earthquakes happen every 10 minutes. So Idaho has a much lesser rate of seismicity than the global average, but earthquakes are happening all the time globally, and in Idaho as well.
Tora asks, what should you do during an earthquake?
Right now, the best policy is to drop, cover, get under cover, and hold on. What we recommend is getting under a desk or a table or something strong that can hold up a lot of weight. Because the thing we have to worry about with an earthquake is things falling from overhead. One thing that we recommend is actually looking around your room or your house and making sure there aren't objects hanging up high that can fall down. If you see something, make sure you can either secure it onto a wall or take it down and put it at a lower spot. One thing we also recommend doing is covering your head or your neck, because those are the most dangerous places, and that's where you can get hurt the most. We don't recommend you run. We recommend you stay close and just get by something. Sometimes it's even safe to get by a filing cabinet if it's strong enough, but don't go very far and cover up. That's the most important thing.
It's game night for the Boise State University football team. And the area around the stadium is filled with tailgaters. For these fans, it's all about the pizza, the football, and the science. For several years, the Boise State Geosciences Department has tracked how BSU fans shake the ground during a game.
What we're observing here is effectively the same thing that we observe when we record normal earthquakes. There's a source that pushes on the ground, and then that energy has to travel through the ground in the form of seismic waves.
Johnson uses these tailgating lab sessions to show students how seismographs work.
So basically what happens is anytime the earth shakes, the seismometer can potentially pick it up. It converts ground motions into small voltages that travel along the coil. You can see this coil of copper wire right here.
Yep.
It induces a current in that coil because there's a magnet inside that is suspended upon a spring. When the ground moves, that magnet goes up and down, causes a current, comes out this wire right here, and we measure that as a voltage. Okay. And that goes directly into our computer. Right now, we're listening to earthquakes from Bronco Stadium, right?
Yeah.
Now, Bronco Stadium is producing tiny little earthquakes as people are cheering on the football team.
Okay.
But because we're so close to the source of those micro-earthquakes, they show up on our monitor. I can see it right there. That's the crowd getting all excited about kickoff. There's the start. Everyone's roaring. They're shaking the stadium. And we're getting those seismic waves. Whoa, there we go. Right there, there's some activity from the Boise State Broncos fans. This is a non-conventional study. Usually we use seismometers to record real earthquakes, and we're listening to human earthquakes.
And what did the data tell these scientists? Something similar to what they've learned in past years.
A study that was done in 2009 actually observed the level of seismic noise decreased over the course of the football game. The first half was a lot more energetic. Maybe people were less tired. In the second half, perhaps people were tired or even left the stadium.
Johnson says the study also shows that there's more than one kind of earthquake.
But you can get a traditional earthquake, such as fault rupturing rock. That's what we call a tectonic earthquake. You can get an earthquake from a volcano erupting, or from a landslide. Or in this case, we have little earthquakes produced by people who are yelling and screaming and stomping their feet.
If you want to see a seismograph in action real time, check out my blog on the Science Trek website. All right, let's go back to your questions.
Hi, my name is Libby. I go to Kamiah Elementary School in Kamiah, Idaho. My question is, how many kinds of earthquakes are there?
Well, generally we have 3 different types of earthquakes, and the way that well, I guess there's only one kind of earthquake, and that is when the earth is shaking. But as geologists, we record 3 different types of movement. It's whether 2 blocks are sliding next to each other, whether one block is falling down from another, or whether one block is climbing over another. So we call those strike-slip faults. We call them reverse or normal. Most earthquakes fall under the normal or strike-slip category.
Now, there are also other types of earthquakes that result from non-tectonic forces. So that means earthquakes can result from volcanic eruptions, earthquakes can result from landslides, and earthquakes can even result from things like Boise State University football games. But those are not the traditional tectonic earthquakes that most of us are talking about right now.
Gavin would like to know, do other planets get earthquakes?
Yes, other planets can have earthquakes. Or let's just say solar bodies have earthquakes, because there are moonquakes that happen, and seismologists have measured them. They've left astronauts left seismometers on the moon and actually are able to measure moonquakes. The way that we actually would tell if there's earthquakes on other planets is we have to look at the surface of the planet and determine if there are faults or if there are surface faults that we can see when satellites are taking imagery of other planets. And I believe we know that there are Venus quakes and Mercury, I think it's Mercury quakes, and it's likely that other moons of Jupiter might have earthquakes or might have quakes. But they might be driven by different processes. As Jeff mentioned earlier, convection is what causes a lot of the earthquakes on Earth. And on other planets, if it's a solid core body, or if there isn't convection happening in the planet, it might be caused by gravitational pull. For the moon, it can be caused by lunar pulls, or the tides pulling back on the moon, which actually cause these quakes.
Elizabeth would like to know, does a moonquake do bad damage to the moon?
Moonquakes are observed by seismometers that were left by Apollo astronauts in 1972 and left on the moon for 5 years. And I believe during that time interval, some 30 earthquakes were detected over 5 years. So the amount of earthquake seismicity occurring on the moon is much less than it is on Earth. It's not negligible, and they're very interesting earthquakes or moonquakes to study, but their magnitudes and the frequency of occurrence is much less than that on the Earth.
Avery asks, how far do tsunamis reach on land?
Tsunamis are controlled by lots of variable factors, and how far they can reach really depends on a lot of those factors. One is how much displacement happened in the water. So if it was caused by either a landslide or by an earthquake, was there a lot of water displaced? And then the distance it goes sort of depends on the topography or the shape of the Earth. If you have really steep mountains, a tsunami won't go very far up them, but if you have a lot of flat ground, it can go very far. It can go several kilometers in length, especially if you're in flat places like Indonesia, where the earthquake happened. It went very, very far inland because there isn't a whole lot of topography to stop the wave from coming in. In places like Alaska, they've seen inundation from tsunami, or marks where the tsunami left a wave that's over 1,000 feet high. So there are very big waves that approach, but how far it goes inland depends on the topography.
Hi, my name is Will, and I go to Dalton Elementary School. My question is, what causes Earth's tectonic plates to move?
This is a very interesting question from a scientific standpoint. Tectonic plates move and are driven largely by processes that occur deeper in the Earth. Underneath this thin crust of rock that we live on is a whole ocean of more fluid rock called the mantle. And the mantle is moving around very slowly but very steadily over eons and eons. And this movement of the mantle carries along with it the Earth's surface, which we call tectonic plates. So it's the underlying ocean of mantle rock that is pushing on the surface plates.
Hi, my name is John, and I go to Eagle Middle School. How many earthquakes of any scale happen each year?
There are hundreds and thousands of earthquakes that happen every year. In Idaho, last year, there were 388 earthquakes. Most of them couldn't be felt by people. The largest earthquake that happened was a 4.9. But on a worldwide scale, it's hundreds of thousands of earthquakes happen every year.
Before we run out of time, Dennis, let me ask you a question. Why did you want to become a geologist?
Well, when I was in college, I was trying to figure out what I wanted to do, and I was taking a lot of classes in a lot of different fields. But what I knew was I liked science. I liked the questions it asked, and I liked the answers I was able to get from it. I liked being able to see how processes happen and how things work. So when I took a geology class, I found a place where scientists go outside and study a lot and do a lot of hiking and looking at neat rocks and neat features on the Earth and try to determine how those features got there. So I knew pretty early on that I wanted to do geology when I was in college. And then from there, I took courses that gave me the experience that I would learn to do the kind of work that I do, which is mapping.
And Jeff, if someone is interested in finding a job in this field, what should he or she study in school?
So geoscientists are people who study earthquakes, and in order to become a well-rounded geoscientist, it's necessary to have good mathematical skills as well as good written skills. So pay attention both in math class, science class, and in English or language arts.
Thank you both. I'm sorry we've run out of time. Dennis, thank you for answering students' questions.
Thank you very much, Joan. Great answers, Jeff. And hey, students, those were some really great questions. Keep thinking of good questions.
And Jeff, thank you as well.
Joan, thank you for the opportunity to speak. It's been great fun.
Our thanks also to the folks here at Boise State University's Seismology Lab for hosting us. Now, do you have a question for an upcoming show? You can email it or send it as a video question, recorded on your cell phone, tablet, or webcam. Or for an educator, we'll even lend you a camera. If you send in a question, you and your class can win prizes. Our last prize winner was Sean, who's homeschooled in Illinois. So to find out more about today's topic, go to the earthquake section of the Science Trek website for facts, links, lesson plans, and more. Or watch Science Trek, the web show. So send in your questions, and each week, check out my blog for the latest science news for kids. You'll find it all at idahoptv.org/Science Trek. Thanks for joining us, and we'll see you next time here on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/Science Trek.